Hi students, last class we discussed about Galileo's experiment of motion of an object on an inclined plane. So Galileo made first attempt to study the motion of an object. So for that we considered an inclined plane. So this we have taken as inclined plane. For a moment it's a very smooth inclined plane. So we need to consider that. Very smooth means if you drop something, so that object just like slips. There is no friction on that plane. So this plane only we known as smooth inclined plane. Suppose if you drop the ball on the smooth inclined plane, now the ball is reaching to other side. Now again it reaching back. Now if you can make any clear observation, now if I can take from here the ball height from here to here, it has a height h. Now when the ball went to other side, so it is also reaches to as a same height h. So this is the first observation made by Galileo. If a marble, so here it is the object is taken as marble. Marble means a steel ball. You can take that, or we are using that glass marbles to play that kancha. So that is known as marble. Suppose if you release that marble on an inclined plane. So now in this case the marble is reaches to as a same place again. In the second case, so the marble always reaches to as a same plane. Sorry, same height. Now, if you can change the angle, so now here you can see the angle has changed. Now, in that case, if you can release the ball again, now again the ball wants to reaches to as a same height. Now, instead of the angle earlier we have taken, now this time you change the angle at here. So, if you can show the angle at the previous case, now here you can see the angle. To measure the angle, suppose if I draw the perpendicular at here, now these are the angles. Now in this case these two angles are the same. Now if you can take to the other case, suppose if you can take these two as another case, now here the angle has changed. Now if you can draw an angle at here, now here you can see the angle to the earlier case to this case, the angle has changed. Now if you can drop the marble in this case, again the marble wants to reach to the same height. Now it reaches to the height h at here. Now the marble reaches to same height h at there. Now these are the observations made by the Galileo. Now again if you change the angle in this case, again the marble reaches to same height. Again you change the angle at here. Now if this angle has changed on the other plane, the marble reaches to same height. Now for final, if you can take, if there is no another inclined plane on the other side, now the other side you make as in a flat, so it's just like flat surface. It's not a inclined plane. Now in this case the ball wants to reach the same height, so it is going to find where the height is. So if the surface is frictionless, now here you can see the ball wants to search. So the ball it wants to reach same height. So that's why the ball will move forever. The ball will be moved forever if this is a frictionless surface. So these are the observations which is made by Galileo. Now if you can see that when a marble rolls down an inclined plane, its velocity increases, and when it goes up the second inclined plane, its velocity decreases. Yeah, if you can take, this is the marble the case. So in this case, so this is the first case, the marble always wants to reach to the same height. So when it is reaching from here to there, the velocity of the marble goes to decreases. That's common sense. Now if inclination of the both planes are the equal, so it means the angles at here what we measure, that those only we are called as inclinations. So then the marble will reach to the same height which is rolls down. Now for the second case, if the inclination has changed, for the second case, again the marble wants to reach to the same height. So for the third case, it is also to the same height. So if you can change the angles, so the marble wants to reach to the same height. Finally, if you can make the inclination plane as a horizontal, if you make the inclination plane horizontal, the marble will travel forever. So the marble will travel forever trying to reach the same height. So from the observations, so the Galileo made a conclusion that an unbalanced force is required to change the motion of the marble. So here I am reading the statement again. An unbalanced force is required to change the motion of the marble, but no force is needed to sustain the uniform motion of the marble. So this is the final conclusion which is given by the Galileo. So by using the Galileo's observations, Galileo has made a statement, and after so many years, Newton gave laws of motion. So he studied Galileo's observations. From his observations, Newton made certain laws. So that laws we are going to learn today's class. So the first law, Newton's first law of motion, states that an object remains in a state of rest or in uniform motion in a straight line unless compelled to change that state by an applied force. It's a statement, try to understand it carefully. An object remains in state of rest or uniform motion. Let's understand that first. Let's see this PHET stimulation. So Newton's first law says an object is in the state of rest or in the state of uniform motion unless if there is an unbalanced force. So this is the Newton's law statement. First of all, let us observe this first. Suppose if you do not apply force on this box, you are not at all applying force on that box, so just like that it kept like that, will the box move? So that's the question right now I am asking to you. if we do not apply force on the box? That's the question. If we do not apply force on the box, will it move? The answer is no. The box won't move at all. So that is the Newton's wants to say. An object is in the state of rest. Rest means nothing but what? It won't move. Or if an object is moving itself. If an object is moving itself. So let me clear some space. Suppose at here I have chosen carefully no friction. Here the friction is 0. See, here you can see. So this is an ice surface. On the ice surface, friction is 0. Now this law has to work with this statement. Now on this ice surface, I am going to apply a small force. Now that is the force I applied. Now I applied force and I left. Now you are observing carefully now. Is the box is moving? Again my question. Is the box is moving? Answer is yes. Now here you can see the Newton statement. An object is in the state of uniform motion. Now the object is in the uniform motion. It is moving in a straight line. Now this box, here my object is box. Now this object don't want to come to rest. It is something is unbelievable. So how it happens? Again I am telling, if any object is in the state of rest, suppose this this fridge is in the state of rest. Now this fridge wants to in the state of rest always. Now this box is moving. If it is moving, so it wants to move always. So it wants to move always. So that's what something is observed by the Newton. So again I am repeating the statement carefully. So the statement, if you can see, if an object is in the state of rest or in the state of uniform motion. So in the two cases, the object always wants to be in that state. It don't want to change. The object always wants to be in that state until unless if there is unbalanced force. Now here the box is moving, still the box is moving. Now I want make to stop. I want to make it stop. What can I do? So two things here I can do. So the one thing which I can do at here, so if I can apply a force on the other side. Now I applied a force on the other side. Or if I can increase the friction. Now if I am applying the friction, now here you can see friction is acting opposite direction. Now the friction is on the surface. Now this surface is having friction. Now do you notice? Is the box is came to rest? Yes, now the box is at rest. Now it is at rest. How did you bring the box to rest? We applied an opposite force. So here the opposite force is nothing but what? That is friction. Now that opposite force is only nothing but unbalanced force. So let me explain, let me recall what about the unbalanced force. So this you already remember. Suppose if I pick up my team, one is the blue team. So these two persons I picked up, and here also my red team. Now here you can observe the arrow mark shows the net force on the right side and the net force on the left side. Now if I hit the button go, now they are applying force. Now here the question. Now will the cart move? Will it move? The answer is no. The answer is no. Why? Because the forces on the two sides. So these two forces are balanced. If the forces are balanced, then the cart won't move. So it won't move at all. Now, if I take one person extra to any of side, I would like to take on the blue side. Now here you can see the cart is moving towards to the left side. Now why it is moving? So here the forces are unbalanced. If the forces are unbalanced, so then only the object moves. So that's what the Newton's law said. So Newton's law says that if an object is in the state of rest, so now again the box, it is in the state of rest. It is in the state of rest. Suppose if I take the frictionless surface, now if there is no friction and if I apply a small force on the box, now what happens? Now it is in uniform motion. Now the box is in uniform motion. So the two things happens. If an object is in the state of rest, it wants to be in the state of rest forever. Or if an object is moving with uniform velocity, it wants to be in uniform velocity. How long it will be? Until unless when an external force applied. External force applied. So here my external force is nothing but what? I want to stop the box. I want to make it stop. So what shall I do first? Now here I would like to increase the friction. Now if I increase the friction, now here you can see I applied external force. So here my external force is friction. Here my external force is friction. Now the box is, now the forces are unbalanced. Now the box comes to rest. So this is the law which is given by Newton. So that's why this is also known as Newton's first law of motion, or it is having another term which is known as law of inertia. Now again I want to just give the final statement about the Newton's law. An object remains in the state of rest. Now the coin is on the cardboard. So this is the cardboard. The cardboard is kept on a glass. Now the coin is on at rest. Now if we flip the cardboard, now the coin is dropping on the glass. The coin is not flying with the cardboard. So the coin is straight away falling on the glass. Why? Because the coin is in the state of rest. So it always wants to be in the state of rest. So that's one of the example which is given. Now, finally, I can conclude this statement by saying that if an object is in the state of rest or in the state of uniform motion, in the state of rest or in the state of uniform motion, that is also in a straight line, until compelled to change, compelled means not agree, compelled to change the state by applied force. Now, why they don't want to change? If an object is at rest, suppose this pen is at rest on the table, so that pen don't want to change. Now that we will say that it's a natural tendency. It means that's one of the property, natural tendency of the objects to remain in the state of rest or in the state of uniform motion. So that natural tendency only called as inertia. It's a very important term. If you take this book, you can keep it on the table. The book always wants to in the state of rest. Why? Because of its own tendency, because of its wants to. It wants to stay in the state of rest. Its own tendency. So that only we are calling as inertia. Or if an object is moving, it wants to move continuously. Why it is? Because it is its tendency, its nature. Moving object is its nature. Now that nature only we are calling as inertia. Students, try to learn that word carefully. Inertia, try to understand it carefully. So inertia is a property. We can say that as a property. So who is having the inertia? Every object in this universe is having the inertia. Inertia is a tendency, it's a natural tendency. I hope you are getting the meaning of what is the natural tendency. That it's nature. The moving objects also having nature, or the objects which are at rest, they also having this nature. Now they don't want to change that nature. They don't want at all to change that nature. So that's why the first law is also called as law of inertia. The Newton's first law is also called as law of inertia. So if you want to write the law of inertia statement, so you have to write the same statement. An object remains in the state of rest or in the state of uniform motion until unless when we applied an external force.